Going on, this is the introduction to Python for Math 143 lab walkthrough. This is the lab walkthrough, so I kind of do assume that you watched the lecture videos and you knocked out some of the exercises. That information is going to help you with this lab. I'm just trying to walk you through it, make sure you know how to submit it, what's all expected on it, and you don't have any issues understanding anything on it. Python, for this introduction either way, is the introduction, like I said, to Math 143. Keyword there being Math 143. This is a math class, not a Python class. Python is just a tool that will be used to replace Excel in traditional Math 143. They use Excel as a calculator and a spreadsheet. So we'll be using Python as a calculator and generating graphs and spreadsheets. On this page, there's a takeaway here, how to launch Python. You may not be able to launch it like that depending on what your environment is. It does say that this class environment is Python Linux, but for this particular exercise, it doesn't really matter if you're on Linux or Windows or whatever. You can still do the lab. The course downloads has a downloadable version of Python that you could use for the class and all the instructions on downloading it, installing it, and everything. I already have it installed on my system. Obviously, you may have it as well. So depending on what setup you have, you may be able to launch it simply by typing Python, right, in your terminal. So make sure it's a CMD or terminal for your Linux. And this is most important. Make sure you see that symbol there, lets you know that you're on the interpreter. We are using the interpreter to run Python for this class. And the lab itself is a fillable PDF. So as you see, I'm jotting down notes on it. You can do the same. And that's how I expect you to submit the lab. Just jot your answers down. You can show all work if necessary right on the PDF, and you could submit the document like that. As I said, you should have watched the lecture video and done the exercises. It does explain the order of operations. We're using Python as a calculator, so it must use the order of operations. You can't just type in however you want and expect Python to understand you. Python understands the order of operations. So look at the example here. We would understand that as 5 times a value that's in parentheses raised to the second power, right? Python won't understand that unless we type it in how it is here. We must use that symbol for multiplication. We must use that symbol for exponents, and everything else can be the way that it is, and Python wouldn't interpret that the same way we would interpret that. And that's how we would use Python with the order of operations. Keep that in mind. You're going to need that to answer these follow-up practice questions here. Excuse me. Like for this one here, we see 2 to the third minus 4. We would understand that's 2 times 2 times 2, right? Minus 4 over 7. You can't type it like that in Python to get the answer. So in this box here, we want you to put in how would you type that in Python for Python to calculate the value for you. That's what goes in this box. Don't calculate the expression and put the answer in here. In here goes how would Python calculate the expression, right? So you got a few examples there. Make sure you follow your order of operations, and how do you input values into Python using the symbols and things like that. For part 2 here, the concept that we want you to take away is using variables. For this lab, we're creating a spreadsheet type of thing with a graph, and when you're using spreadsheets, Excel in particular, what's used traditionally for this class, you would create variables and cells and reference cells and use formulas inside of cells. So if we're going to be using Python, we have to have a way to replicate that behavior. So we use variables. And in this box, it shows you briefly how to assign a variable. We're assigning the value 2 to the variable x. If we want to call that variable, we would simply type x, and then Python would give us the value that's stored in that variable as 2. If we want to change variables, like how we would do in spreadsheets, if we want to assign different variables for our formulas, we could easily do it in Python by changing the name that we, well, actually just the value that we give to the variable. You see how here we gave 2 as the variable value. Here we would change the value to 1. The variable stays x, but the value, if we call it, would be 1 now because it was changed. In Python, that's called reassigning, right? So we would reassign variables. And we can do that as many times as we want. It's not really important that we get that it's called reassigning. It's just important that we know once we assign a variable, we can change it. It's something that can be changed. And we can assign multiple variables. Here they assigned A, B, C, D, the values 2, 3, 4, and 5. If I want to call the variables, I would just call them by name. If I call C, C is given the value 4, it would give me 4. If I call D, D has the value of 5, so it would give me 5. And that's just the basic concept that we want you to take away. How to assign a variable, how to call a variable, how to reassign a variable once you gave it a value, etc. The most important part of the lab is part 3. In the lecture video, we covered this concept of creating X and Y values from a formula. But in this instance here, they want us to do the same thing and then use those values to create a graph, which we will be learning moving forward in this course, how to use that concept in different areas, because we're going to be using a lot of graphs in quantitative literacy to examine variables and values and connections between different things. We use graphs sometimes to visualize the data. So we have to learn how to create our graphs, and this little exercise here gives us a little help with that. So let's unpack what we're looking at. It says that a system generates activity based on the formula y equals 3x plus 5. We'll learn in future lessons that that's the formula for a linear equation. So if I plot this on a graph, I should get a linear graph. It should be like a line, a straight line. That's what this formula represents. But at this part of the class, we don't know anything about that, so that might be foreign to us. All we know is that this question is asking us to generate values for X and for Y based off of that. So let's try to unpack that as easily as we can. We know that we have to get X and Y values, right? We've done this before. So we don't know what the values of X are. We can just give them random values. We did 1, 2, 3, 4, and 5 as the values for X, right? So that's what we did right here. We created a variable called X values, and we made a list. When you see brackets like that, that's a list. And inside the list, we gave those values that we created for X. 1, 2, 3, 4, and 5. That's our list, right? So same thing, like if we were going to go to Excel and do the same exercise, we would have to write X, Y in a cell, write 1, 2, 3, 4, 5 in the cell, and then we would write the formula in the cell for Y equals 3x plus 5, and then we could drag that down, and then it would fill in all these values for Y. That's what Excel would do for us, right? But we're replacing that. So Python would allow us to see exactly what's going on under the hood when Excel does that operation. So what is it doing? Like y equals 3x plus 5, 3x plus 5 being the dependent, like y is dependent on what 3x plus 5 is doing, right? So if my value of x is 1, my value of y depends on that. Y equals 3 times 1 plus 5, right? And then y equals 3 times 2 plus 5. Y equals 3 times 3 plus 5, given the value of x, right? I would have to do that 5 times in this case, right? If there were 6, 7, 8, 9, all the way to like 120 values in that list, I would have to do that 120 times. Or if I were in Excel, I would have to drag that all the way down to 120, right? That's what I would have to do. It could get tedious after a certain point. So how do we replace that is what we're trying to conceptualize with Python as a replacement to Excel, right? I want to replace all this. I have to do this all these many times, right? Or drag this all the way down here. So in order to handle that situation in Python, we already have the values of x that we created. We made a variable for that called x values, and we put the 1, 2, 3, 4, 5 in there. We already did that, right? Now, in order to get our y values, we can use Python and what we call a loop construct. Loop construct. What the loop construct allows me to do is something repeatedly, right? Repeatedly, something that I did X amount of times, right? I did this one time, this one time, this one time for all of the values of X in my X values. I had to do it for 1, I had to do it for 2, I had to do it for 3, 4, and 5 in order to get my values for Y here, right? So for X in X values simply means for X values is the variable that I created. X in this case would be every one of those values that I have in that list. So this would be x1, x2, x3, x4, x5, right? That's what for X in X values means. That tells my for loop how many times it's going to do something. It's going to do something for this one, for this one, for this one, for this one, and for this one. 1, 2, 3, 4, 5, right? What is it going to do? Well, it's going to do the same thing that we were doing up here. We were doing 3x plus 5, okay? So for every x in X values, every x in X values, Y values, right? So now I'm going to do something to Y values. Y values is right now an empty list. It has nothing in it, right? Empty. I want to put something in Y values every time I reach a value for X. And what I want to do is I want to dot append. We see dot append, right? That one. What dot append does is it adds something to the end of a list. Add something to the end of a list. What am I adding to the end of this list? 3x plus 5. So how does that work? For 1, I'll do 3 times 1 plus 5, and I'll put that into my empty list in the back of my empty list, right? Then I'll do 3 times 2 plus 5. I'll put that in the back of this list. So it will push the numbers to the left, right? So if the first number in there was 8, and then I put 11 as the second number, but in the back, and then the third number I put behind that 14, and then behind that I will put 17, because that would be 4 times, or excuse me, 3 times 4 plus 5. 3 times 5 plus 5 would be 20. And that's how I would generate the values for my list, and they would be in order, right? Because I started from 8, and then 8 was pushed over here so that 11 can go in, and then 8 was pushed over here, and then pushed over here, and then finally it ended up in the front of my list, right? So I have X values. I did this math 5 times, and I generated values for my Y values. So now I have my Y values and my X values. That's all I really needed, right? I needed a way to get X and Y values without having to physically do them 100 times, and without having to drag this line all the way down 120 times. Python did it. It's called an automation, right? So it automated the process of me assigning these variables into that list. Now, once I have the X values and the Y values, I can create a graph, visualize that. So that's what we're doing here. And this is the last part of the lab. You have to import a plotting library. So in Excel, when we're going to plot a graph, we insert the graph. So in Python, this is like insert graph, or actually, I think it's insert chart or something like that, right? So in Excel, you would insert chart. So this is the same thing as import in Python. Python, we would import matplotlib is the library that has functions and modules that we would need to create different types of graphs and charts. So if we import it, we're able to use those modules and libraries, right? Now, the important part here is how to set up. So we're just looking at this code right here, and it's very easy. It's very similar to what you would have to do in any spreadsheet to set up your graph. We already inserted the chart. What kind of chart are we working with? Well, we want to use a scatter plot, right? So in Python, working with matplotlib to create a graph, plt.scatter, I'll leave this blank. In here, you would put in your X values and your Y values. If you didn't name them X values and Y values, you named them something else, whatever you name them would go in there, right? Now, why did I say PLT? Why couldn't I call it whatever? Because right here, when I import it, matplotlib.pyplot, I said as PLT. That is why I'm calling it PLT whenever I call it. If not, I would have had to call matplotlib.pyplot.scatter, matplotlib.pyplot.plot, and that would just get tedious. So this is a short name to call our import multiple times as the setup. So we have to call it multiple times because we're going to tell what kind of plot we want, a scatter plot. That's the chart. The next one, plt.plot, is telling Python to actually plot these values, your X and your Y values. Plt.title is the name of the graph. We need to name our graph. Plt.xlabel that is our x-axis, and then plt.y label is our y-axis. All that's the same information that you would have to put on any graph. And then this is just how we would do it in Excel, in Python versus Excel. You're not required to remember any of the setup in this class. So right here is something similar to what you would get if you were needing to use this on a lab or a test or whatever. And then you would just fill in your X and Y values. You would put in the name of your graph, fill in what the title for your X axes and your Y axes, and just fill in what goes in the parentheses. Make sure you use your comma in there and use the proper syntax. We'll help you with the syntax in the lecture videos, right? So this is what you'll be provided with. You just fill in your values, and then this command here, plt.show, make sure you have your parentheses at the end of it, because you have to run that just like that. We'll run these values here into a graph, and it will present your graph. So you will get a graph output. This is pretty much similar to what you would get once you run those. So if you notice, this is our title of our graph. We have our X and Y axes labeled, and if we wanted to put more information inside this graph, then the code here obviously would have to reflect that. This is just the basics of how to get the graph, and that's all this lab was, just the basics of how to get your graph. You have a few questions after that. You can fill in your answers right in here and submit this PDF by email. Once you want to exit, this command right here will exit Python for you, and then you'll be back in your regular environment on your laptop or your computer. All right, very basic lab, walks you through pretty much some of the things that we learned in the first week of class. Good luck. If you have any questions, make sure that you just reach out to me. A side note real quick, for this class, the only two charts that we're really going to be working with are bar charts and scatter plots. So if we're using matplotlib, this same code works. If you wanted to do a bar chart, you would simply plt.bar and then put your values in there, right? Very simple, basic, nothing to worry about. I hope that went by smoothly for you guys. You understand exactly what we need for you to submit for this lab, and good luck. See you guys in the next lesson.